So this leads me on to railway-oriented programming. And my apologies, Rob, there are no steam trains at all in this video. I couldn't figure a way to fit them in. I really couldn't, despite the title. No, not even diesels. I know, it's terrible. How many of you have heard of railway-oriented programming? No? Ooh, you have?
Yeah, yesterday.
Okay.
Fair enough.
No, I watched a video on it, and it's actually it's an interesting concept.
It wasn't Scott's video by any chance, was it?
No. Yes.
Okay, awesome. So railway-oriented programming is a term coined by Scott Wlaschin, whose name I've probably just butchered. My apologies if Scott ever sees this. And he runs a website called F# for Fun and Profit. He's a functional programmer by trade, originally a Smalltalk programmer if memory serves. And in 2014, he did a video where he coined this phrase. That's where the phrase comes from. The video's online, you go watch it. If memory serves, it's about 1 hour, 5 minutes long, something like that. So it's longer than I'm going to spend on the concept. So if you like the ideas I share tonight about it, please do go watch Scott's original video and get it from the horse's mouth. Okay? Especially as by the end of this, my take on it will be different to his by the time we're finished with the code walkthrough. But please do go watch that video. He's a nice bloke to watch a talk for. He knows his stuff and he's good with the audience. So what is it? If we take a function and draw it diagrammatically, that's where the railway approach originally comes from in Scott's mind. You have an input, you have an output, and you've got some code in the middle, which Scott in his talks calls the tunnel of transformation. I promise I'm not going to use that phrase very often, but that's the phrase Scott uses. And as you can see, hopefully on the right-hand side of the diagram, put a couple of little arrows on there, and it looks like a railway track. Okay, so that's how Scott in his talks talks about code, and that's how he started talking about it and gave it the term railway-oriented programming. And let me give you a concrete example to show how the diagramming works. So if we take something we all use all the time, converting a string to uppercase, and we draw it out diagrammatically. There's our railway track with our tunnel, our code. We input a string, and we get back out a string. That's diagrammatically how you draw a railway-oriented function. That's all there is to it, almost. And so if we pass in the string apple, we get back a different string, which is apple in uppercase. And it's important, this is one of the very fundamentals of why this technique works, is a different thing comes out. If you change the input data, you don't modify it, you create a new value that you return. The original input data is always left unchanged. And that's starting to tackle the problem of side effects, because you're no longer changing state in other objects. That's the basic idea. If memory serves, and I'm not a functional programmer as I've mentioned, so I could be butchering this, it's part of the concept of what they call a pure function in functional programming. But I could be wrong with that, and I'm sure there's other aspects of pure functions that I'm not covering in this. Now the thing is with this approach, is if you've got a function that behaves in this way, and you start to write a few more, you can actually take them together and glue them together and build bigger bunches of logic out of it, which is tapping into something in functional programming they call composability. And once again, I'm sure there's more to composability than this particular aspect of it. So go find a functional programmer and say, I've heard this thing, it sounds really good, but what is it actually? Because the guy talking about it didn't know shit. Okay. Now, Scott's interest in railway-oriented programming actually came from error handling. If memory serves, his talk's title is Railway-Oriented Programming, a Functional Approach to Error Handling, or something like that is actually his talk title. So what do you think goes wrong? Sorry, what do you think we do when something goes wrong with this approach? If we take our diagram here, and I've picked validate email because it's something more businessy, something we're actually more likely to do. So we pass in an email to be validated, and it fails validation. What would you do?
Anybody?
It's down to consumer observation, isn't it?
What would you do?
No, so you pass it back to the consumer.
You pass what back?
The information.
Oh.
So you,
Okay.
so there's essentially like with any decision, and,
Right. Okay.
there's a yes or no.
Is it yes or no? So
So
you're talking about returning like a boolean or something.
Yeah.
Okay. What would everyone else do? I'm sorry, I don't know your name.
Sorry, it's Richard. It just seems it's a standard thing where you would you present an error message.
You present an error message. So would you return that, or would you do something else? There's no wrong answer. There's no wrong answer. What do you do today?
I just kill the application.
You kill the application. I don't think anyone's going to top that answer.
I've got an exception.
Throw an exception from Rob here at the front. Okay.
I kind of like the idea of actually having two, but well, this kind of
Yes.
goes along with what I would normally do anyway.
Right.
Which is basically, if it passes, go to this function.
Uh-huh.
If it fails, go to that function.
Okay.
That's how I would normally program.
Okay.
But this is interesting.
Okay.
So just to summarize then, we've got return something back. That's an invalid message of an invalid piece of data of some kind to tell the caller that there's a problem. We've got return an error message. We've got throw an exception. We've got launch into orbit and nuke it, just to make certain. Okay. In railway-oriented programming, we have a second track, a second output. Although Scott doesn't talk about it quite in those terms, but I'm going to. This is where I'm going to vary slightly from how Scott does it because we don't have a functional language. So the idea is there's two outputs. You've got the data and you've got an error message if there's an error, is the idea that comes out of this. As has been mentioned, we could throw an exception. We're going to come back to exceptions towards the very end of the talk. Scott does tackle exceptions in his talk because functional programmers hate exceptions, it seems. And he introduces a concept called the pyramid of doom. I couldn't find a demonic-looking pyramid, but an office block to me just seems the perfect analogy for that. I don't... Isn't it just? So if we look at hopefully you can read this code. If we look at a very contrived example, I'm well aware you can reorganize this code so that you return early, so you don't have all this nesting. But all you're doing is reorganizing the code. Conceptually, it's still working as if it was nested, okay? And the idea is all this nesting, where you're moving from the left-hand side, from your perspective, left-hand side to right-hand side of your editor screen, is called the pyramid of doom. Scott introduces. And Scott's focused a lot on why it's a really bad thing and why you should eliminate it using railway-oriented programming. All joking aside, for me, there's two problems with this. Those nested ifs make, especially inside one function, make testing more hard work. I assume you all do testing of some kind? Or you're not going to admit it on camera at least? TDD. Okay. But the second problem with this, especially in business logic, which is where we're going to be focusing a lot of the talk on later on, business logic has to change, because if businesses don't change, they die. And if you've got lots of nested complexity like this, over time, as you go in and change these things, it gets more and more fragile, and you start shipping more bugs and less working code. Things that used to work break, you get regressions, and unless you've got a good test suite, you're not going to catch them in time. And that's what happens on commercial systems world round. So those are the reasons why the pyramid of doom is a bad thing. And Scott's argument is try-catch blocks are just another form of pyramid of doom, basically in his video. But go watch his video. He's far more eloquent about that than me. Now, can we replace it with relational-oriented programming? Sorry, railway-oriented programming. Can we replace it with that, and can we do it in PHP? If we take this function, and we isolate the individual steps, we can actually break those out into individual functions, very small functions. And if we make sure their inputs and outputs are compatible, we can compose them together into a pipeline. This is why returning a Boolean or a piece of garbage as the return value doesn't work, because you really want string in, string out, or whatever. In this case, it'd be string in, string out because it's an email that you're passing around. You want that so you can actually chain the things together in a pipeline without having to write a lot of glue code. And we'll show you that in more detail when we get to the code examples. Now, we mentioned before about errors. So there's actually two outputs coming out of these functions, not one. hopefully we're all on a happy path along the top and everything's just working. But if there's an error, you drop down to the error track and you don't need to run the rest of the pipeline. You can short circuit the pipeline. Now, that got me thinking, and this is something I don't remember Scott covering in his talk. Actually, we'll get to that in a moment. One more slide first. These functions, they're not composable as things stand. One input, two output. You can't really glue those together very well. So how would we fix that? What would you do about it? If we go back to this for the moment, what would you do about it? How would you fix that to make it composable? Bear in mind, I've only introduced the composability about 10 minutes ago.
Create a type that can be either one or the other.
Okay, you can't do that in PHP. PHP's type system is incredibly primitive. No, that's the functional answer. That's what functional programmers do. But they have a type system that's actually powerful.
Create an object?
PHP is not object without objects.
Okay, so create an object.
In this particular case,
Yeah.
I wouldn't even think about this. I mean,
Okay.
Sorry.
No.
Those three checks
Yes.
you're doing, I would just combine them into a single function and group them together and ask if those three
Okay.
were valid.
Okay.
So I wouldn't try to string three separate operations.
Okay.
I'd actually have one operation.
I would probably flip it on its head, start in a really simple format and always return an empty string. Okay. And then that way the next function knows, oh, the string's empty, there's no point in continuing. Okay. So I'd flip it on its head, start with the most simple validation first, like, is this a string? Yes. And then move on to the next one.
Okay.
Move on to the next one. So that's
What if the next function received the string and it was empty, but the user actually stuck an empty string in? How would you know if it's an empty string the user put in, or it's a default value?
That's a very good point.
yeah.
Then the other issue is I would actually have two exit paths for the function.
Two exit paths, okay.
Really want to attach a different function to there.
You want to attach a different function to the error. That's another solution. In railway-oriented programming, we can solve it by actually having two inputs. One is related to errors coming down the pipeline, and the other one is the primary data coming down the pipeline. This is where I'm starting to divert slightly from how Scott presented it, but bear with me, it will make sense by the end, I promise.
Oh, I finished. I stopped watching the video halfway through.
Oh, right. Oh, awesome. In that case, I'm sure Scott would approve if he ever saw this. No, he wouldn't. Oh, dear. But we can compose them because we've now got assuming the types are compatible, of course, because we've got two inputs and two outputs. Those are things we can easily glue together in PHP. And I'll show you how easy it is shortly.
So do you start with a default error of null or something as well?
What we start with is this. We make the error optional, an optional parameter. What we're going to do for now, as we're introducing the concept, we're going to say that we start off without an error conceptually, and therefore it's an optional parameter. And we'll revisit that by the end of the talk. So one of the points I'm trying to get across is we no longer have to write loads of bespoke logic to do validate email or whatever business function you're trying to do. You can actually compose it from lots of smaller functions that can then be easily reused in different contexts in different projects. And I accept in this case, it's not obvious why you'd break those up. I accept that. We do have better examples, I promise. But this is good, this feedback's important. So who decides, though, when we stop calling this pipeline? Who decides that? If we look at this diagram here, do we decide that in the blacklisted function? Is that code that decides it? Who decides?
Would you define the type to the error and then the mailbox decides?
Let me ask a different question, or let me put this question in a different context. Okay? I don't know about you, but I hate submitting a web form and getting the errors drip-fed back to me one at a time. I hate, loathe, and detest it. I will go and use your competitor's product if you do that to me, okay? So with this pipeline, if we short circuit partway through because it's baked into the code inside the pipeline, your system's going to do this behavior, which For me personally, pisses me off, no two ways about it.
Yeah, but the flip side.
There is, let me finish first. Let me finish first before you say that. Now, we've deliberately been designing these functions to avoid side effects, which means when it makes sense, we can run the whole pipeline when it makes sense. It won't always make sense, depending on the type of validation you're doing. But sometimes it might make sense. Take an address, for example, for a business. There's two types of validation you do. First of all, does the address exist? Secondly, is it registered to the business? If the address doesn't exist, you'd short circuit that, because there's no point checking to see if the address is registered to the business, because that's a meaningless error. Yeah? But there'll be other circumstances where it does make sense to go all the way through. Yeah?
So it depends.
It depends. So my argument is, this short circuit logic can't live inside the functions that you're composing together, because they don't know the context they're running in. They don't know what you've got coming down the pipeline. They can't know. So if you can't put the short circuit logic in there, it's got to live outside it. And that sort of completes the concept of railway-oriented programming as I'm presenting it. You've got input parameters, you've got one parameter which is your main piece of data, and you've got something to do with errors. That's a bit vague, and we'll firm that up as we go along. The functions themselves, their job is to apply logic to data. They may be doing a transform. They may just spit the same data out. That may be, with no error, that may be what they do. It may just be a validation, a check of some kind. But they never change the input data so that you're eliminating side effects. And then the outputs, you've got two outputs. You've got the data, which may have been transformed, in which case it's a new value. And you've got something about any errors that have occurred. And that's likely to be something to do with aggregating the errors. And then finally, in order to do composition, we want to control this short circuiting, because when I was taught how to do engineering in the 90s, we were taught a concept called policy, which is who decides. Libraries with policy are not very reusable because they are designed to work in the context of the author of that library, because they're making decisions, they're opinionated. But if you want to use them in an app in a different context, that app needs to hold the policy, it needs to decide. So we want to keep that outside of these functions. That's railway-oriented programming, my take on it in a nutshell.